Let's take a look at jthread. Jthread, as it says here, it has the same behavior as to thread, except that jthread automatically rejoins an instruction and can be cancelled, stopped in certain situations. If we look at thread, it says here in destructor, if the thread has an associated thread, then terminate is called. In practice, you want to use jthread, which is available since C++ 20, but not every compiler supports it yet. If we look at the compiler support, you can see that stop token and jthread is not supported currently by Apple Clang. I'm currently on a macOS machine. I installed GCC to get this running. If you have the option to use jthread, I definitely recommend using it over a thread, because this behavior where it rejoins an instruction and it can be cancelled, stopped in certain situations, is just what you want in practice, because you often want to associate a thread with an object, have control over the lifetime of a thread easily. So now let's start writing our timer with jthread. So yeah, when writing a timer, I essentially mean writing an object that will call a certain function over a certain interval. And we can use jthread to tie the lifetime of the thread to the timer object. So let's see how that can look. Let's begin writing our timer struct. All right, so what we want to pass it to the timer is, first of all, an interval, and we can use the chrono library for that. We're going to pass a chrono interval to our timer. So it's going to be the interval on which the timer will call the callback. Let's call this interval. And the second function will be our callable. So let's make this a template. The template type will be a callable, which we'll take here. All right, so jthread will become part of this object. To use jthread, we need two headers. We need thread, which has a jthread object, but to use a stop token, which we'll get to, we also need stop token, because stop token is going to allow us to stop the thread within the thread when the thread wants to be stopped. Our timer will just wrap the thread and won't do anything else. So the constructor will just be empty like this, but we need to initialize the thread. So what does jthread take? Let's take a look. All right, so let's take a look at jthread constructor. We have 4 options here. We're going to take this one, where you can pass in a function with arguments. We're going to leave out the arguments for now, but you can pass in arguments that will be forwarded to your function, essentially. So let's put in a callable there. Let's create our timer. Let's give an interval of, let's first also use this namespace just to make our life a bit easier. So let's say the interval is going to be 1000 milliseconds, and then we pass in our lambda. So let's just print tick within the lambda. Okay, I think I'm doing it completely wrong. We need to use this callable in our own callable. So I think this is going to be a lambda, because now we can have some loop here. Let's just say while true for now, where we can end every loop with a sleep. Okay, so we need to capture the interval, of course. All right, this makes more sense. I also think that the template can actually become part of the constructor, not necessarily the class. And then here, we'll just call our callable, which also needs to be captured. Now, the nice thing with jthread is that we can change this while true to something where we abort if the jthread is trying to be destructed. And the way to do that is that you take a so-called stop token here, and then you can say while not stop requested, do this thing. So it's going to call our callable and sleep for the interval as long as the token stop requested is false. When this object is destroyed, it's going to set this flag and it's going to quit our lambda. All right. Let's print some things. Let's put this in a scope so we can see what happens when it goes out of scope. When it goes out of scope, we can see if the thread has actually stopped running. Let's put in a sleep here for like 5 seconds so we can see that the timer has stopped and that there is no tick callback anymore at this point. Let's see if this does something. Started, timer destroyed. Okay, sure, we need some sleep here as well, of course. So let's have the timer running for 5 seconds. Yeah, so you see we got 5 ticks, timer destroyed, and then application ends after 5 seconds after timer destroyed. Cool. So here's our little timer. There's a few modifications you could make to this timer to improve it or to tweak it to your need. The first one is you might want to consider putting this callable after the sleep. So your object begins with a sleep and then the first callback happens after the interval. A second improvement that could be made, which is maybe more subtle, is the amount of time it takes for this callable to do its work isn't taken into account when sleeping. It depends on your application whether this is relevant. Let's say this is used to just blink some LED or something like that, and the accuracy is not super important and the time it takes for this callable is neglectable. Maybe this is fine, but maybe you need a high accurate timer where the interval between the start of each callable is exactly this time. Then you need something else. You might need to measure this time or something like that. Another way you could improve this, although it also depends on your need, is adding maybe a start and stop to this timer, because maybe you want to be able to stop the timer while it's running and then restart it without needing to recreate the object. So yeah, those are a few ways you could improve the timer. Might make another video about that. But this is already a great timer.